Hello guys, welcome back to yet another video on this channel. However, we're changing things up today. As you can see, I'm recording on my iPad right now, and it's not the only difference. I'm also doing, finally, a math review video. So after my January musical grind kind of, sort of, semi-worked, it got me to gold, so I guess I might as well do a math grind. And my goal is to basically make a video every single day, just as I did during the winter break grind. So today is first day, and we are reviewing the AMC 10A 2022, and this is probably just going to be a part 1 of the 3 or 5 or 6, I don't know, however many videos I'm splitting this contest into. So let's just get started. Problem 1. As you can see, this is basically just brute calculation. We have 3 plus 1/3, that's obviously just 3/10, and so on. We just brute calculation until finally we get 109 out of 33. No tricks required. Problem 2. It is also just brute calculation. As you can see, we have 57 minutes for all the laps. However, we only have 27 of the 57 minutes do we care about, so it's that times 15. Some brute calculation without any skills. Still, we get B, which is 7, approximately. Problem 3, obviously, this is just a simple system of equations. 3 numbers x, y, z. X equals 6z, and then z equals y minus 40. And then we're trying to find the absolute difference between the first and second number. Oh, and also the sum is 96. How convenient is that? 3 variables, 3 equations. Simply we solve that and discover the sum to be 5. P4. Now this is one that I consider actually kind of challenging from now on. So we have fuel efficiency that we're trying to calculate. 1 kilometers is equal to m miles. 1 gallons is equal to L liters, right? And one of the biggest tricks in this problem is that the fuel efficiencies are measured in the 100 km per, liters per 100 kilometers, while in other countries is miles per gallon. See, the key difference is the fuel are switched around. Liters came first in one of the countries and gallons came second. So that is the biggest trick. But however, if you just do some very standard exchanging of units, we have x miles per gallon in one country times, well, 1 mile is 1/nth of a kilometer, and then times 1 gallon is L liters, and then we have to flip it around, which means we get 100 lm over x, right? We have to also divide that by 100 before flipping around, because we're finding 100 kilometers for every letter. Okay, that was a very terrible explanation, but I think you get the idea, because there's mainly just one trick in the problem, is that one is liter came first and gallon came second in the units. Pretty weird. P5. This one gets a little bit more straightforward. You just have a square, and then you have 4 points on each of the sides, and then somehow they formed a convex hexagon, and it's also a regular equilateral convex hexagon. And now you're trying to find the side length. Obviously, since we know the whole side is 1, s is equal to this, right? Which is equal to 1 minus s times root 2, because this is 1 minus s. And this is also conveniently a 45-45-90 triangle, because, well, obviously those two sides are equal, so those two sides are equal, so it's 45-45-90. After you solve for s, it is pretty obvious to be 2 minus root 2. Just solve for s. Problem 6. This is also a problem that kind of tricked me when I mocked this contest. So we know a is less than 0, so a is a negative number, which means square root of a minus 1 squared is going to be absolute value of a minus 1, which is going to be, because this is going to be a negative number, so this is going to be positive, which means we have to flip this whole thing to be 1 minus a instead, after getting rid of the absolute value, because we know a is less than 0. And then everything is clear from that. A minus 2 minus 1 minus a, which is equal to a minus 2 minus 1 plus a, which is equal to negative 3. The heck? Wait, did I do something wrong? Oh, I did not, because absolute value sign. So the answer is oh wait, I messed up. A minus 2 minus 1 plus a is going to be negative 3 plus a, but we know a is a negative number, so this whole thing is flipped. So instead of a minus 3, it's 3 minus, instead of 2a minus 3, is 3 minus 2a. Yes, I am a bum. Problem 7. Okay, this problem we have n and 18 has LCM of 180. And we just kind of prime factorize. 18 is obviously 2 third cubed. This is 2 third cubed times 5 times 2. And then GCD of n of 15, n of 45 is 15. Which 45 is obviously 3 squared times 5. 15 is 3 times 5. And then play around, n is obviously 60, which gives you the sum of 6. And then we look up problem 8. Problem 8 is just one of those problems that you just kind of like know it from first glance, but it does take you a while to actually solve for it. It's obviously x is, so first let's arrange the data sets. It's gonna be 1, 2, 5, 5, 7. X is only in those possible spots, and the medium is just gonna be 2, 1, 2, 5, 5, 7, or x itself, and you just basically solve the equation for what x could be for each of the value of absolute, for the medium, for each of the value of the mean. You solve for x because there's only one variable and you have one equation. Easy peasy. 9. Okay, this one is also kind of obvious, but you might make little mistakes like I did and I got the wrong answer. So first of all, we kind of just want to do combinatorics, in which first we add up all the cases in which every single rectangle has different colors. That's just 5 factorial. Plus there's also the case in which triangle number, let's actually number the rectangles. Why do I keep calling them triangles? 1, 2, 3, 4, 5. If rectangle 1 plus 5 is the same color, we add those possibilities. 2 plus 3 is the same color. 3 plus 5 is the same color. And then there's also a possibility that 1 plus 5 and 3 plus 2 both have the same color. However, those two have different same colors. So just gotta consider all of those possibilities. Problem 10 is also a good problem that I really like because I did mess up again. Obviously, x squared plus y squared is equal to 8, and x minus 2 squared plus y minus 2 squared is equal to 4 root 2. Both of these two must also be squared. And you just solve for x and y, and you do some tricks, and you don't actually have to find x and y, you just have to find their product. Which, I mean, you could turn into quadratic and then use the Vieta's formula, or you can just do some smart tricks playing around with it, and you just get x times y by itself, which gives you the area of the index card being 18. However, I did make a mistake when I was doing this, and I thought it was x minus 1 and y minus 1. I know, what a bum. Number 11 is one of those problems that are going to be really easy for us who does coding because, well, 4096 is obviously 2 to the 12th. So 2 to the m's times 2 to the negative 12th, well, because it's 1 over 4098. That is equal to 2 times 2 to the negative 12th mth root. And solving this equation is going to be a piece of cake for us who can already get to 2022 AMC 10A, so I'm not even going to go over how to do this. The answer is obviously 7. P12. I actually really like these logics problems because it doesn't require as much math, and as long as you're smart, you can basically solve it. First of all, the main thing to determine in this problem is what does the alternates say on the first try, because the alternates answer on the first question determines their answer for the next two questions as well, and only if we know that can we solve for number of alternates, number of good people, and number of bad people. However, notice that on the last question, the good people will tell the truth and say they're not liars. The bad people will lie and say they're not liars. Only the alternate have a chance of saying that they are liars. And the principal gave 9 pieces of candy, which means that there are at least 9 people who answered yes, which means the alternates all answered yes to the last question, which means there are 9 alternates. And from there, you can solve for good people and bad people, and in the end, you see that the answer is obviously 7 for the number of non-liars. Now comes one of the favorite problems in which I did solve during the mock is problem 13. Problem 13 is a geometry problem, as we can see, and we have to take a little while to actually analyze the graph and draw the triangle out. We have triangle ABC like this, and then somewhere on there is point P, in which BP is 2, PC is 3, and then AP is also just happen to be perpendicular bisector. What a coincidence. And then the line that's perpendicular to AP intersects the line that is parallel to BC at point D. And now we're trying to find the distance of AD. So there are several different methods we can use to solve this problem, in which my method that I developed during the contest and I did not see in the solutions was similar triangles like this. Notice 2 and 3, and these are similar triangles because vertex angles. We can tell that the ratio between, say, this OP and PQ, OP and PQ is going to be 2 to 3. And then comes the kind of insane part that I remember. I think what I did was I realized that there are another pair of similar triangles that we might have not discovered. Because look, this is 2, this is 2, which means that this is also 2 compared to these sides. So 3, 3, 3, 2, 2, 2. So there's another pair of very strange similar triangles the solutions did not notice. Well, they did not need because they had a smarter method, but basically this is also a pair of similar triangles, these and these. And if we utilize this pair of similar triangles with the base being 2 and 3, we notice that the ratio of A to O and O to Q is going to be 2 to 3. With this in mind, we notice that since we know this is 2 and 3, this is 3 for the total length times 2 fifths. This is 3 times 3 fifths, basically ratio-wise, and this is 2. And since we know these ratios, we can just find the ratio between BD and AD, because that is another pair of similar triangle, and I'm going to denote it with a different color. AD, no, wait, actually, yeah, it's this one and this one. These two are also similar triangles, because obviously. So now, since we know the side, the ratio is, I need a different color, what should I use? Purple. 2 to 3 times 2 fifths. We just have to find the ratio. We just have to find AD using BP, which is obviously 10. I know this idea does look very overly complicated. It was indeed the only thing that I was able to think of during the contest. However, the solution had a much smarter method. I'm just backspacing right now. Okay, a much smarter method is just to utilize similar triangles of this pair. This is the method that the solution utilizes. We used ABO and AOQ, I guess. No, there's a Q over there. We're just getting rid of it. The solution does not need this perpendicular line at all. ABO and AOQ are completely congruent, right? And then we also know, according to angle bisector theorem, the ratio between this side and this side is going to be 2 to 3. And we also know, since these two sides are congruent, the ratio between AQ and QC is just going to be 2 to 1. And since this whole thing is 5, and this whole thing is just going to be 5 times 2, which is 10. A much smarter method compared to mine. Much faster, but, well, I didn't know the angle bisector theorem, or I couldn't think of it during the test. So whatever. Now on to P14. 14 was also a good problem that I was able to solve. First, let's list out 1, 2, 3, 4, 5, 6, 7, and then 8, 9, 10, 11, 12, 13, 14. Notice how all of the top numbers can only be the greater of each pair, because even the smallest of the top numbers, which is 8, cannot be the smaller of any pair because 2 times 8 is 16, which exceeds the largest of 14. So since we know all of these are upper, all of these are lower, we just have to pair it from the biggest. 7 can only be paired with 14. 6 have 2 choices. 5, regardless of what 6 chooses, has 3 choices. Maybe this or maybe this. And then 4, regardless of what 5 and 6 chooses, have 4 choices. 1, 2, 3, 4, and so on and so forth. Actually, it could not be 4. It doesn't matter though. So on so forth, and it is obvious that the final answer will get 144 choices. P15. Alright, 15 is another geometry problem that I was really proud of myself for being able to do during the mock contest. And it is also, unfortunately, the last problem that I was able to complete during the contest. And, yeah. So we have a circle wall. That is a really perfect circle that I just drew, except for the second half. We have a quadrilateral in it, if I can actually draw this. Alright. And then we have 7, 24, 20, and 15. And now we're trying to find the area that are outside quadrilateral and inside the circle. So the shaded area of this. And see, the only way that I knew on how to solve these problems was, well, there has to be some special property with these numbers, because other than that, there is absolutely no way that I could possibly solve this. And I just guessed right angles, which happened to be true. Because if we draw a line down the middle, we notice 15, 20 is not just the Pythagorean triples, 3, 4, 5. So this will be 25, and 7, 24, 25, that does work. So that means right angle, right angle. And with that being said, we also notice that this is the diameter of the circle because these two are right angles. So from there, this problem is easy to solve. Okay, now on to problem 16, which I was not able to solve during the contest. Okay, why that? Still right in pink. And not even a contest really, it's just a mock contest. So we have this cubic function. Obviously we can't just solve it, that's going to take us way too long. So let's just think of something that uses some AMC style tricks. Let's say the 3 roots are x, y, and z. So the prism, the enlarged prism is just going to be x plus 2 units, y plus 2 units, z plus 2 units. That is what we're trying to find, right? That is equal to our answer. And if we multiply that all out, it's just going to be a very complicated bunch of numbers. But we're still going to do it. X, y, z plus 2xy plus 2yz plus 2xz plus ... I'm just going to say ... here. However, notice that every single one of these terms are not individual x or y or z's. They're merely a product of these numbers. And we can find these using Vienna's formula. Remember this? Remember this? Remember this? See, if we use all of those, we don't have to solve a single one of these roots, and we get every single value. Anyways, yeah, classic AMC trick. We never actually solve cubics. Well, unless, I mean, you could bash it out with just synthetic division, but ew, who likes synthetic division? Okay, anyways, honestly, I think this is pretty good for one video. I had a bunch of, I don't know if I call these notes or just scribbles, and yeah, we went through 16 of the 25 problems. The rest of the harder problems I will probably do in a different video, and this is really just a starter for a new channel. Well, not new channel, but a new series of AMC grind. Hopefully this will have the same effect as the January grind videos, in which I did get the gold. I mean, eventually I did, not in January, but eventually I did, so I'm just hoping for Amy sometime within my high school career. So, good enough. Anyways, thank you for watching. If you're still watching, I doubt anyone actually make it here, and even if you do, you're probably my parents who didn't really understand math. Or maybe you're not, then thank you so much for watching this far, and please subscribe. Thank you for watching, and I'll see you tomorrow. I really hope we do, because I might forget to make video, or I might just